Done. Love it. Okay, so first 6 questions. X equals means it's vertical. Y equals means it's horizontal. Y and X together means the thing's oblique. So we got a vertical, a horizontal, an oblique, a vertical, and a horizontal. Writing an equation to describe each line. This is going to be X equals 3. This one's going to be Y equals -2. This one's going to be X equals 0. Graphing each of the following lines, this one's going to look like this. Y is equal to 1.5 is going to go right there. And X minus 3 equals 0 is going to be right here. Because when you solve for X, it's going to equal 3. So then D, graphing the following lines, I didn't specify which way, a table of values or Y equals mx plus b. Now, for my own curiosity, hands up if you did a table of values. Hands up if you did the Y equals mx plus b route. Hands up if you didn't do the question. Okay? So what does this line look like? Those of you who did Y equals mx plus b, where is the y-intercept? Is that negative 3? So there should be a dot right there. And then what is the slope? It's 1 over 1. Okay, so it's going to look like this. And I can connect these dots. Yes? So that's my line? Yes? That's a very good question. So let's set this thing. I'll take this question. This equation is in standard form. We're going to take it. We're going to put it in the slope-intercept form. To do that, we're going to solve for y. So my first step here to solve this thing for y is I'm going to add 2y to the other side. I want to get that positive. So we're going to add 2y. We're going to add 2y. So we're going to get 2x equals 6 plus 2y. Then I'm going to subtract 6 on both sides. Bless you. 2x minus 6 equals 2y. And then I'm going to divide everything on both sides by 2. So I'm going to get y equals, and then it's going to be 2x over 2 minus 6 over 2. So then this is 2 over 2 is just 1. So it's going to be x minus 3 equals y. Now the slope piece comes from the coefficient on the x term. That's our m. If there is no number written in front of a coefficient or in front of a variable, we assume the coefficient is 1. So I can throw that in there. But we don't want it to be just 1 because we want it to be a fraction. We want it to be the change in y over the change in x. So the whole number 1 can be written as what fraction? 1 over 1. So it's going to be, I'm just going to add, just to make it really clear so we understand what's going on here, I'm going to make it 1 over 1 x minus 3. Now, you would never see it written like this. You'd see it written like this, y equals x minus 3. But I'm trying to be real clear so that we can see if there is nothing written in front of it, the coefficient's a 1, and I want it to be the change in y over the change in x, so it's going to be 1 over 1. Does that make sense? That's how we get the slope. But you would only ever see this thing written like this. You have to be able to go from this y equals x minus 3. You'd have to do this. You'd have to understand the 1 over 1 piece is what this means. And then go from there. Okay, so that was the first chunk. Bless you. Questions, comments, concerns? Going once, twice, thrice. Great band. Sold. Flip page. Kyla wants number 9. Does anyone want anything before number 9?
No.
So I assigned 1 to 12. Does anyone have any questions on 1 through 8? 1 to 12, 13a, and 14. But 13a and 14. So the only reason I asked if anyone has questions on 1 to 8 is because Kyla asked number 9. So I'll do number 9, but I won't do anything first. Let's do 8 first. Does anyone have any questions before 8? Going once, twice, 3 times. So what I'm hearing is you did the homework, you checked it, you're cool with it, and we're moving on. Okay, here we go, number 8. Which equation best describes the graph below? Explain your choice. So this is our y-axis. This is our x-axis. So the line that we're dealing with is this darker one right here. So is that going to be an x equals or a y equals line? It's going to be an x equals. So I can get rid of some things here. I can get rid of this one. So now I've got x minus 2 equals 0, 2x plus 1 equals 0, and 2x minus 1 equals 0. So what I want to do is I want to solve those 3 equations to get x equals some number. What is this thing going to be? This one's going to be x equals what? It's going to be x equals 2. Is this line x equals 2, the green one here? No, because that would be over here. What would this one be? 2x plus 1 equals 0. If I solve that one for x, what's it going to be? Negative 1/2. Is this green line x equals negative 1/2? Yes. So then we're done. My answer is B. That make sense? Okay. Number 9, Kyla. The sum of 2 numbers is 15. Let P and Q represent the 2 numbers. So the easiest thing to do here is actually to start with C and then do A and then do B. So if the sum of 2 numbers is 15, what's that equation going to be? P plus Q equals 15. But I don't want it in that form because that's standard form. Let's put it into slope-intercept form just to make our life a little bit easier. Slope-intercept form just means I'm isolating for one of the variables. So, Kyla, which variable do you want to solve for? Q? P? Does it matter? Doesn't matter. You choose. You could do that. You could do that. I wouldn't, but you could. The only reason that bothers me a little bit because you have y equals something with x, the bigger letter, the quote-unquote bigger letter. You can do whatever you want. There is no right answer here. Conventionally, I would do q equals 15 minus p, but if you want to do p equals 15 minus q, there's nothing wrong with that. By doing that, Kyla, you have declared which variable to be the independent variable? Which one's the independent variable? Which one is now the variable that we're going to change to give us the other variable? Q is the independent variable now. So now when you complete your table of values, Q is going to go there, P is going to go there, and we're going to choose values for Q that are going to give us values for P. So then, it wants 6 values. It wants 6 values. So give me 6 values of Q, and we'll just shove it through there. Kyla, go. 6 numbers off the top of your head. Bam, go. Bam. 0. Sure, negative 3 works. Do positive 3. 4. 7. And sure. Okay. So if those are my values for Q, what are my P values? Well, if Q is negative 3, what's P? It is 18. If Q is 0, what's P? If Q is 3, what's P? If Q is 4, what's P? Next one, 7 and 10. Done. And then graphing the data should be relatively easy. Sorry? The way she wrote this, Q is the independent one because we change Q and it's going to give us P because P. You could do Q equals 15 minus P. Yeah, sure. Yeah. But the way Kyla wrote, the way she wanted to solve this equation, defined Q to be our independent variable. Again, like I said before, there is no right or wrong choice there. That's just the one she made. I would have made the other one just because I am a little bit neurotic with my numbers and my letters. That's just, again, neither one of us is right or wrong. And then you get a graph. The question then, so graph the data. It's going to look something like this. Where's my y-intercept going to be? Oh, which line is going to be P and which one's going to be Q? P is the vertical axis, yeah, which makes Q the horizontal axis. Where's my P-intercept going to be? What's the value for Q on the P-axis? No, what's the value for Q? It's 0. So where Q is 0, what's P? 15. So up here somewhere, I'm going to have the point. This is going to be 0, 15. Then we want to graph some other points here. I would have negative 3 and 18. So where's negative 3 and 18 going to be on this graph relative to my intercept? To the left and up. So that right there is going to be the point negative 3 and 18. Let's do one more of these 6 points. Let's do 4 and 11. Where's 4, 11 going to be relative to this point here? To the right and down. Because this is 0, 15, I want 4, 11. It's going to be there somewhere. So now, can I connect those dots? Given the context of this question, am I allowed to connect those dots? Correct, because I can have any fraction of numbers to add us up to 15. Because it did not specify integers. If it said the sum of 2 integers was 15, would I be allowed to connect the dots? No. But if it didn't say integers, it just said any 2 numbers. So we connect the dots, and you're going to get a graph that looks like that. Obviously, your graph's going to look better, because you should have done it on graph paper. I just crammed it in the corner there for the sake of the question. That is number 9. Kyle, that makes sense? Cool. Anybody else comments, questions, concerns from the homework I assigned yesterday? Happily. Write the equations of the lines that intersect to form a rectangle. So this is your shaded rectangle here. What are the lines that intersect to make that shape? Well, you've got one right here, one right here, one right here, and right there. So what are those 4 lines? What's this one? That's going to be x equals 4. We cool with why that is? Okay, it's a vertical line, so it has to be x equals. And it's over here at 1, 2, 3, 4. So that's going to be our x equals 4. So this guy right here, the vertical line here is going to be x equals negative 1. This bottom one here is going to be y equals negative, what did you say? Correct. And the top one's going to be y equals 3. Love it. That's it. That's all you have to do. Cool, Akam? Questions about 13a or 14? 13 was just a graphing the following lines. What shape do they form? What shape did they form? A square. Cool, love it. If you said it was a rectangle, is that also correct? Because are all squares rectangles? Yes, but are all rectangles squares? No. So if you said that this was a square, I'd say you're crazy. But if you called a square a rectangle, I would say technically you're correct, which is the best kind of correct. Right. Also the most irritating kind of correct for other people. Construct a congruent shape on the graph with one of its vertices at the origin. A shape the same size would be 13b, but I decided 13b. So it would be a square with the same side lengths, but you'd put it at the origin instead of wherever this one was. And then 14, are we cool with 14? Yeah. Actually, 14 is a long one. Comments, questions, concerns, no issues? I just, for whatever reason, I don't know why they do this. They get you to write the equation at the very, very end. To make your life easier, I would definitely do the equation first. We good? Did Angel's answer? Angel, who were you answering? You're asking a question. Do you have a satisfactory answer to that question? Because I'm pretty sure the thing that I just heard you say was correct. So. Yeah. Yeah. Cool. Going once. Twice. Thrice. Sold. Cool. So that's your homework. Let's take a look at this second last lesson here, matching equations and graphs. So this is going to extend kind of what we did yesterday. And this is where, if you get comfortable with the slope-intercept form of these graphs, it's stuff like what we're going to do today that's going to make your life so much easier. If you're able to operate in y equals mx plus b and don't have to go to a table of values. A table of values will always work. It's just more work. And, you know, lazy is good in math. The right kind of lazy. Doing as little of the required work as humanly possible, but still doing the required work. Okay, so here we go. We want to match the equations with the graphs that pass, and these ones we're going to pass them through the origin. Sometimes they're not, but this passing through the origin is relatively easy. The equation of the graph that passes through the origin will be of the form what? Yes, Carolyn. It's just going to be something that like this. Y equals mx. Well, I don't know why I put that above the line. That should have been right on the line. Because why?
Because b could be 0, possibly.
B is 0. It's not could be. It is, Danny.
Oh, okay.
Why? Why is it 0?
I'm not sure. Well, I think I do know. I just don't know right now.
So what I'm hearing you say is you think you might know, but you don't want to say because you're not confident in your answer.
No, but I just don't. Yeah.
Okay, that's cool. I'm fine with that. B is 0 because the origin is what point? It's 0, 0. So we're just looking at the form y equals mx, where m is just going to be some number, some real number. We want to match each graph on the grid with one of the following equations. So I've got y equals 3x, y equals x, and y equals negative x. These ones, again, you have a choice with all of them. Either use a table of values or slope-intercept. And I'll show you what both of these look like. Yes, Carolyn? Okay, so Carolyn is saying that graph A is y equals negative 2x. Let's prove it using which form? What do you want to do? Slope-intercept. Okay, so we're going to use slope-intercept on this. Hold on, yeah, we'll get there. You're right. You're absolutely right. That is the shortcut. So, I was working with a student yesterday, and they decided to call slope-intercept form SIF, and I like it. So we're going to use SIF. Y equals negative 2x using slope-intercept. At this point, we've graphed a lot of things. Things that have a, or when we're using slope, if the slope is, we had a change in y over a change in x. Okay? This thing is, what is the slope on y equals negative 2x? It's negative 2 over 1, which means what? So and a negative 2 on the y means I'm doing what? Am I going up or going down? I go down 2 for every what? Every 1 x in the which direction? Right. Because if x is positive, I'm moving to the right. Y is negative, so I'm going down. Okay? So from my origin, I want to go down 2 and over 1. Oh, look! What line am I on? I'm on graph A, as Carolyn said we would be. So using slope-intercept form, SIF, if you're able to pull the slope and recognize that, okay, well, I've got a change in y over a change in x, so as my y drops 2, I move 1 to the right in x. So let's do it from the point that we were given, the origin. Oh, look, and we're good. So graph A must be y equals negative 2x. Love it. Now, let's do the first one. Y equals 3x. 10 meet. How'd you do it? Okay, so you also use slope-intercept form for this one. She used SIF. We recognized, you said it was 3 up over 1. So from the origin, I went up 3. I went over 1. Oh, look. What graph is that? It's graph B. So graph B must be y equals 3x. The last one is easy to use a table of values for. So we're going to make a table of values. There's going to be my x, there's going to be my y. The equation is y equals x. So if x is 3, what's y going to be? 3. If x is 2, what's y going to be? If x is negative 4, what's y going to be? So let's plug these values onto my graph and see what line they end up with. 3, 3 is going to be right there. 2, 2 is going to be right there. Negative 4 is going to be right there. What line have we stomped all over? That is graph's line C.
What would be the...
So that equation is going to be y equals x. So it doesn't matter if you use a table of values or a slope-intercept form. Does anyone want to see either of the, like y equals 3x or y equals negative 2x down to the table? Nika's got a different question, okay?
How did you figure out that it was like the, down in the or
Oh, okay. So like you're looking at this one or this one? Okay. So 10 meet looked at, so she's using the slope-intercept form. So the coefficient on the x in the slope-intercept form tells you what this ratio is here. I'm going to zoom this thing in here. I don't know if you were here on the day we first looked at this ratio. But this ratio is when we were identifying whether or not a graph was linear, we were looking at the ratio of the change in y's over the change in x. And on a table, as long as that change is consistent, I mean the same everywhere, then our graph is linear. Well, what we were able to do is we were able to connect that ratio to meaningful information on a graph. So this ratio, the change in y over the change in x, is equal to 3. Well, when you have a fraction that's equal to a whole number, the denominator is 1. So if I have a change in y over a change in x equals 3 over 1, and they're both positive, a positive change in y means I'm going up. In this case, I'm going up 3. A change in x that's positive, in this case positive 1, means I'm moving to the right. So we were told the question says we're starting at the origin. So the origin is this point here, 0, 0. So we're told that my change in y is positive 3. So from this point, I'm going to go up 1, 1, 2, 3. and my change in x has to be 1, positive 1, so I go 1 to the right, and there I am. That's how Tammy did it.
So
Danny.
3 over 1 is the same as 6 over 2. So
Yes.
just continue that up. What if
Yep.
you had
It's
negative 6 over negative 2?
It's the same thing.
Would that still
because it would reduce to the same fraction.
Okay.
So it would take us down, we don't want 6, that's bad. Let's do negative 3 over negative 1.
Okay.
So I could have gone down 1, 2, 3 and left 1. That would have been equivalent because negative 3 over negative 1 reduces to 3 over 1,
Right.
which reduces to 3.
Okay.
So yes, that would also work.
Because you said we did the other ones with the
Slope-intercept.
Yeah.
Yeah. So you want to do one of these with the table of values?
No, but why did you do the middle one with table of values? I mean, I know they're equal. So
Because the reason I did it is because the two people, Carolyn picked this one and Tanmeet picked this one, and they both picked slope-intercept form, and I wanted to do one with the table of values.
How do we do it without a table?
This one?
Yeah.
Okay, let's do it.
It's really straightforward.
So yeah, what's the number in front here? 1.
Yeah.
So the slope is 1, and 1 is the same as 1 over 1.
Yeah.
So this is going to be y, the change in y over the change in x is going to equal 1 over 1 for my pink line. So we start at 0, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, and we get the whole line.
Okay.
That's it. Does anyone want to see either the green one or the red one done with a table of values?
How about actually,
Yes. Let's do it. So, I've got my table of values, x and y. Harwin, give me 3 values for x. -2, -1, and 0. Okay, so those are my values for x. And now we plug them into the equation to give us our values for y. Yes, Harwin? Yep, doesn't matter. So, if x is -2, what's -2 times -2? It's positive 4. Love it. If x is -1, Harwin, what is y? Correct. If x is 0, y is? Yeah, -0 is a 0. It's a 0. Yeah. So now let's go graph these points. -2, 4 is right 1, 2, 3, 4. Oh, it's right there. Which means I didn't make these perfect on my gut. Oops. -1, 2 is -1, and then up to there is 2. And then 0, 0 is right there. So it lands on that red drawn line. That's how you would do y equals -2x using a table of values. Again, I don't care which method you choose. To use a table of values in the relationship or slope-intercept. Don't care. Next year, whoever your math teacher is definitely going to care. You're going to have to do this using slope-intercept. They're going to want you to get away from the table of values. But this year, either one, whatever you're most comfortable with, I don't care. Okay. So, this one, what is interesting about these two graphs? There's a few things. We're not going through the origin. Okay. That's interesting. So what is that going to give us? Again, there's 2 ways you can do this. The 2 ways you can do this is to make a table of values. Am I off the page? Or slope-intercept. I'll do it both ways. So the question that we're dealing with is, it says, which graph on this grid has the equation y equals 4x minus 2? So, which one should I do first? The table of values or slope-intercept form? Slope-intercept form. Okay, so if that's my graph, what's the y-intercept? So I've got y equals 4x minus 2. It's important to recognize what the pieces represent. This thing right here, the negative 2, is my y-intercept, which I'm just going to call the y. Actually, I'll write it out full. Intercept, which tells us what? Kyla. 10 me? Or how are you going to answer that question?
That's where the line touches the y-axis.
Yeah, and so where the line touches the y-axis is it's going to include which point? Something comma negative 2 is going to be on the graph. 0. At the y-intercept, x is 0. So whichever one of these graphs has the point 0, negative 2 is the one that we want. 0, negative 2 is right there. Oh, look, which graph is it? Graph C. Let's prove it using a table of values. So I've got this relationship, y equals x minus 2. Sorry, 4x minus 2. Table of values is not, it's just more work. Yeah. At some point, it's not going to matter whether you choose the algebra or not. Okay, so we're going to scribble out this checking graph A, B, and C business. We're just going to do the table of values. I've got my x, I've got my y. Someone give me 3 values for x. Doesn't matter what they are, as long as they fit within the axes there. Sure. No. No. It's got to fit on my grid. Okay, careful. Look here. My smallest x value that gives me something on the graph is negative 1, 2, 3, 4, 5. And my largest x value that gives me something to work with here is 2. Everything else is not on the page. So give me 3 x values that actually fit with the graphs that we're analyzing. It's not hard. It's just anything between negative 5 and 2. Amanat, 3 is not between negative 5 and 2. Thank you. Negative 3. Give me 2 more. Negative 1 and 1. There we go. I heard 3 numbers that will actually give us values that work. Okay, when x is negative 3, let's plug it into my equation. I've got y equals 4 bracket negative 3 minus 2. So that's going to give us what point? Negative 12 minus 2 is what? That's equal to negative 14. Okay, let's plug in negative 1 into this now. I'm going to have y equals 4 times negative 1 minus 2 is equal to what? And let's plug in 1. Y equals 4 times 1 minus 2. Negative 5 and 2. Because if I looked at the lines that we were actually dealing with here, an x value bigger than 2 didn't give me a graph to look at. An x value smaller than negative 5 isn't on the grid anymore. So that's why we restricted our values to between negative 5 and 2. And then Amanat picked 3. So what's 4 times 1 minus 2? So that's going to be negative 6, and that's going to be 2. Given the equation that we're looking at, we built our table of values. Now let's plot these points. Where's negative 3 and negative 14? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's down here somewhere. Not super useful. Where's the point negative 1 and negative 6? From here I go where? Left 1 and down 1, 2, 3, 4, 5, 6. Now we've got at least an idea of what's going on here. Now I want the point 1 and 2. From the origin, I go over 1, I go up 2. Oh, look. There's my line. What graph am I on? I'm on graph C. Which one of those is infinitely less work? The slope-intercept form is way less work. Harwin, you had a question. Yeah? I scribbled that up. Don't worry about that. Yeah. There is an alternative way to go about this question, but I didn't want to do it that way. I find this, I think, is an easier way to do it. Table of values, building. So the way I approach, and I want to teach you guys to approach these questions, is to start with the relationship that you're given, and then either use slope-intercept form or a table of values that you build to give you the line that it should be. The way that so I yanked this from someone else. The way that they were going to have you do it was to pick points on these lines to shove into the equation to see if it worked, which I don't think is a useful way to approach it. The useful way, I think, is to start with a relation and then either do some algebra or analyze it using a slope-intercept form and going from there. Comments, questions, concerns? Hearing nothing, flip the page. Now, I am going to give you a block of time to do some homework. This class ends at 11:25. So, the homework is this page here. And then, let me take a breath, Kyla. 3 to 9 and 11C. Do you want to do more than that? Hold on. The lines on the grid below intersect the equation line. Oh, interesting. I also want you to do 12. No, I don't want you to do 12. I want you to do 13. No, just 13. 13 and 12 are the same question, but 13 is harder. So I want you to do 13. So 3 to 9, 11C, and 13. It's not that hard. You guys can do this stuff. Okay, so I am going to give you some time. Let's say we'll check where you guys are at 10:35, which is 25 minutes. And if you've made reasonable progress, we'll jump to finishing off the race around the world. Yes. There you go.